I'm Susanna Pirttikangas from the city of Oulu, University of Oulu. I can see that there are so many Finnish people here, but in case, is there anybody who doesn't know where the city of Oulu is? Okay, good, because I will start with Google Earth flying. So let's first fly to Oulu. So this talk is about Oulu Smart City traffic pilot, so it is essential for you to know where we operate. So let's move from Tavit Center. Fly to Ellis Island. Don't you just love Google Earth? They're so beautiful. Visualizations. Then across the Atlantic Ocean, we can see Scandinavia there, Norway, Sweden, Finland, and then we land to Finland, Oulu. I live a little bit up north from that point. So everybody now get the picture of, let's see if I can get it back on. And now the slideshow. Yes. What's so special about Oulu? This is a very small city, 200,000 inhabitants living in there. But it also means that the piloting of different kind of new services is very easy and flexible and agile. We have the multidisciplinary university in the city of Oulu. We have collaboration with different universities nationwide and of course internationally. We collaborate with the city of Oulu traffic engineers. They are very young and enthusiastic about developing the city further in this digitalization era. And there are other public authorities we work together as well, the Ministry of Transportation and Communication. And there are over 400 companies operating in that area. And recently, because Nokia mobile phones shut down, there has been new startups, hundreds of actually new startups in the area. So this kind of collaboration has led to certain development in the city. So over 10 years ago already, we had the free public Wi-Fi network, PAN Oulu, available for everybody who came into the city. So of course nowadays it is pretty common to have public Wi-Fi, but this was already happening in Oulu over 10 years ago. So there are these access points and Bluetooth access point covering the whole city area and the airport and the university. Just last year, the traffic signaling system was renewed. So from each traffic signal, each crossroads, we get real-time information from the traffic signaling status and configuration data. Public transport info system was built last year, so each bus can be tracked in real time, and these displays show the locations of the buses on the bus stops. So you don't have to worry about if the bus is coming or not. You can see it on the map. We install new sensors when necessary. This is because we operate with the city of Oulu, so they provide us the electricity and communication for our installations or devices. This is an example where we installed laser range measurement devices to each lane in one of the entry roads called Merikoskenkatu of the city. In our laboratory, we have developed an open source crowdsourcing software, Aware, that you can use for crowdsourcing different kinds of information from your own mobile phone and actually do already data processing in the device. And finally, this is the new effort between the University of Oulu and the Technical Research Center of Finland, VTT. So we offer 5G testbed for research at the university and for companies at VTT. So this is kind of the background where we operate. But I also want to mention that the Intelligent Community Forum, ICF, which is a New York-based think tank, has voted Oulu to be the in top 7 of the smartest cities of the world twice in a row. And according to their definition, smart cities are cities and regions that use technology not just to save money or make things work better, but also to create high-quality employment, increase citizen participation, and become great places to live and work. I have a video there, but I will not show it. It's a short one, but I will tell you about it. So one example of these services that are available for the citizens is the this preemption for emergency vehicles. So whenever there's an alarm for an emergency vehicle, the system that operates the traffic lights starts to locate the ambulance or police car or whatever emergency vehicle. The location is sent to the servers each second, and also the turning signal is detected, so you know if the ambulance is going to turn, and you will be given green light across the route in real time in Oulu. So if you come to Oulu, we can take you to a ride where you have free flow in the traffic lights. So just briefly, let's go through those data sources that we have. So we cooperate, all this can be collected from Oulu, but we cooperate with the city of Tampere, with city of Helsinki, city of Lahti, and we expand our ecosystem and our studies nationwide. And some of these data can be collected in other cities also. So magnetic loop data can be collected from the below the normal pavement or asphalt, and it's related to the traffic signaling traffic signaling system. So you control the traffic lights based on this data. Then I mentioned the Wi-Fi. So we have Wi-Fi and Bluetooth access data. So the mobile phones operating in the city. Then we have installed traffic cameras and public transport, so bus location data we can get. And we utilize spatial databases naturally, and we use DigiRoad, which is a national Finnish database. So we don't use so much OpenStreetMap or Google Maps. We have our own slightly better and more quality database for spatial processing of data. And then we have road weather data, which is really important in Finland. In the winter time, I will tell you more later about one of the experiments or services that is related to surviving the winter time. And these laser range measurements, you can use actually these laser range measurement devices to detect the speed of the vehicles, but also the distance between vehicles. You can detect the profile of the vehicle. You can detect the snow, amount of snow on the road. So they are pretty good devices in traffic, because they can provide a lot of different kind of data, but also process it really fast and etc. Then we have taxi cabs. We have location data from the taxis operating in all over Finland, actually. But also we have installed onboard diagnostic connectors in some of the taxi cabs. These OBD2 devices are such devices that can gather a lot of detailed information about the engine of the vehicle. So let's go to my first example. So what's wrong with this picture besides it's taken in the future? Because it's taken today at 9, after 9 in Finland, actually. So they are a little bit ahead of our schedule. So I took it today. So it's again, it's a Google map, traffic map. Do you all know the meaning of the red and orange and yeah, you know. So the Google Maps, they offer this service that you can determine the fluency of traffic in this street network. So green is fluent traffic and orange is mediate traffic, and then there's the red is stop and go activity. And it's crowdsourced from mobile phones operating in the area. Yeah, there's a bottleneck there. But what's wrong with this picture is that there's nobody there, actually. So there must be something wrong in this traffic map. And let's go into more detail. Can you see that? I have the laser pointer. So you can see that there is traffic jams over here and here according to Google Maps. And if we draw our own system, picture of our own system, you can see that there is actually nobody there. But we have a lot of more data sources. And here I have added one additional data source now in this picture, which is these constructions. So at least one of those traffic jams is explained by this construction sign. What about other things? There's a traffic light. So of course there's stop and go activity. But is it a traffic jam? It's not a traffic jam. And actually, when you look more closely, you can see most of those can be explained with the traffic lights. And then if we add information about turnings, then you can see that in such places there's turnings for left, which in Finland we have the right side traffic, so it takes more time to turn left than to turn right, and it's more difficult. So even with actually this information, there's like 2 additional data sources now in addition to the mobile phones operating in the environment. So there's the events, the construction events. This can be also crowdsourced, but it can be provided by authorities. But there's also this spatial database information about the traffic lights and the turnings, etc. So even with 2 additional data sources, you get much more information to this picture. And this is a situational picture, and it is actually pretty important part of creating situation awareness for the different actors in traffic, these kind of situational pictures. I checked in New York, there's a similar kind of traffic map. You have the constructions there, and in most big cities and smaller cities, this kind of map is already available. What we have is unique here is that we get this information from the traffic signaling system, so it's much more reliable than crowdsourced data. So in creating situation awareness, you need information about other drivers, bus locations, vehicles, vehicles behind the corner. These left turns, they are especially difficult for elderly people. You have to be aware of everything what's happening in those left turns. You need information about traffic volumes for rerouting in dynamic conditions, but also for traffic planning to avoid congestion and decrease emissions and increase fluency and safety. So this is all situation awareness. You need information about traffic speeds, fast response on disturbances in the traffic is then available when you have this. And you could add weather information. Actually, most cities provide weather information to create these situational pictures. And you need this direct information about constructions and renovation. And also one important thing in city traffic is the information about parking places. So it takes several minutes usually to find a free parking space in the city. So information about this is pretty crucial. And Finland is actually one of the first countries in the world that have made an intelligent transportation strategy in 2013 in April, but there was already a second generation strategy. And this strategy, it gives actions to be done for different municipalities, cities, different actors that affect transportation. So increasing this situation awareness is a very important part of this strategy. It's one of the actions that in Finland we thrive on. So here are the enablers for situation awareness. So in this talk, I'm hoping to give selected examples of a 4-year project called Data to Intelligence, where we have used the Oulu Smart TrafficPilot as our testing platform. And I'm hoping to give you the examples. They are not comprehensive. I mean, we have done a lot more, but they are selected so that I could show you the requirements that in our opinion are the most important things to be fulfilled when you create these traffic services. So you need a good set of good amount of data sources. You have to have enough data to make reliable assumptions about the situation. And in traffic, the situations emerge fast, so you need fast delivery and updating of information, and you need to update all old and futile information. And traffic is periodical. It means that the morning and day there's different kind of congestion situations. A weekend is different from the weekday. Winter is different from the summer, so you need the past history. What is the usual situation and what has changed? So going through these examples next, I'm hoping to elaborate this further. So the first example is braking distance. In wintertime, the slipperiness of the roads leads to dangerous situations. So while the slipperiness increases, the stopping distance of a vehicle can be over 5 times larger than with a good tire grip of the road. So in Finland, this is especially important to take into account when you make plans or suggestions for the drivers. So this system that we developed, it detects the speed of the vehicles, the distance between the vehicles, calculates the slipperiness of the road, and gives a warning to the driver if in case there's a too short a distance between those cars or vehicles according to the circumstances. So the components of this kind of application are pretty complex. So you need to have a device that collects and measures the speed of the vehicles. In this example, we use this onboard diagnostics device, and the data is delivered through Bluetooth. For distance, you have to measure the distance between the vehicles. We have used the laser range measurement, either in the infrastructure or in the car, and also camera. So you can estimate, if you put a camera in the front window, you can estimate the distance between vehicles from the images. But that is actually not as reliable as the laser range measurement because the weather conditions affect this considerably. And also you need this friction factor that is calculated by the Finnish Meteorological Institute, and it's sent to the mobile phone, and then you need the location data. So what is big data here is actually the weather prediction. So the Finnish Meteorological Institute uses a huge amount of information from the atmosphere collected from different kind of equipment, radars, etc. So this data is so big, so the estimation, the weather prediction cannot be done more frequently than 4 times a day. Each prediction brings 4 terabytes of more data into the system. So this road weather predictions can be done from this weather predictions once per hour because you can update the road weather prediction with new observations. But you can see it's a complex system and there are a lot of different kinds of components within this system, and you need fast delivery of information, as mentioned before, and you need fast processing of information. So it can be done in the devices or in the server where you send the data, in case you have good enough connection to the server. And then you need adaptive user interfaces that do not disturb the driver. So those are the components of this first example. And just today, Kivisudan was opened. Kivisudan, it's the stone heart or heart of stone. It's a new parking garage under the city. So just today it was opened, so you can go and test this new parking garage there. And there's a new kind of service available in the parking garage. So whenever you enter, there's a camera on the entrance that takes a picture of the license plate, and it recognizes the license plate, and it can give you personalized information where to drive your car, and when you leave the garage you can find your car easily based on your license plate. So this is now happening in Kivisudan, but we wanted to test this kind of system further or develop it further. So what if we knew well in advance that you are coming to the city, and you can give personalized services for the driver 1 kilometer before you even are near the parking garage. So there's a traffic camera there installed in Merikoskenkatu, one of the entry roads. And but there was a problem when you have free flow traffic here to trigger the camera in a correct moment. So we realized that we can use the laser range measurement, which is really, really fast, and it can detect the approaching car. So now we detect the approaching car, and based on this information, this camera is triggered, and the recognition accuracy increased a lot of the license plate recognition. So in this system, you need also fast delivery of information, but you also need advanced image processing algorithms for license plate recognition. But with this kind of system, you can improve the information of the other sensor by the other sensor, which is actually very common in transportation area. One source gives noisy information, there's missing data, but you can use the other sensor to kind of repair the other sensor's flaws. And then example 3, individual drivers. According to research, up to 45% reduction can be achieved if you take into account your driving behavior and make better decisions in selecting your route. So this driving behavior consists of your maneuvers, how you stop, how you accelerate, how you decelerate, how aggressively you join traffic when entering the highway, and route characteristics. And then the route characteristics, the number of turns to left and right, the number of pedestrian crossings, route elevation, etc. So we have made a tailored solution to give recommendations for the driver so that they could drive in a more fuel economical way. And this system is based on, again, on real-time information from onboard sensors and the environment. It identifies the personal driving factors and adapts the system's decision-making with respect to the driver progress and responses to the recommendations. So the components are, I will have to speed up now. The components are, so you get the driving behavior from the onboard diagnostic measurements from the engine, then weather information is taken into account, then information about the spatial database and the information about the traffic fluency. And these information are processed, the data is cleaned, the locations are map matched. This is actually a very important part in many transportation-related studies. And actually today I went to listen to the recent development of geospatial processing here, so it has been very interesting. Also there, we need new kind of techniques to bypass this. And all this information, the clean data, the features of the driving behavior and the route characteristics are saved, and then they are processed with different kind of machine learning algorithms. We use rules, for example, to the recommendations. So it is sometimes it is okay to maybe drive more slowly when there's slipperiness on the road. So you can we need to adjust those recommendations based on the environmental context and different aspects of the system. And then there's the fuel economy model, which is also relearned if the driver behavior gets better. And then this information is showed on the user interface or on the web interface. So in this example, we need advanced adaptive data analysis and also informative user interfaces. Sometimes in the previous examples, we could, to a certain extent, operate in an environment where there are no inert energy resource constraints or computational processing constraints. So in vehicles or devices installed in the environment. But what about pedestrians and bicyclers? So there we process on the edges of the network. It is always very heavy energy-wise, energy consumption-wise to push the data into the cloud, and it would be beneficial to be able to reason from data within the edge nodes. So we have two kind of approaches for this, which is the distributed reasoning with lightweight RDF data, and then mobile agents that kind of, it's a structure that takes care of the processing in the best possible place of the network resource-wise. So these kind of information can be spread within the network, and you don't need a central server for this. Just briefly. The aim is to demolish those data processing silos that traditionally are there. So usually you have a company where you have your own data source, and then you have a certain service related to that data. And then there's another company who has the same thing, like in our braking distance example, the weather data. So Finnish Meteorological Institution, they provide weather data for fleet managers or whoever, citizens. And then there's Noptel laser range measurement device, which is traditional. So you can get the new novel services for different partners. So the requirements, let's go through them again. Sufficient selection of data sources, and we need data store to support data variety, volume, and velocity, but also technologies that can be used on the edges of the network due to resource constraints or communication constraints. Then we need versatile data access. We need good query interfaces, spatial data processing. We need rich data analytics and comprehensible data visualization. But we also need understanding about the regulations and laws. We actually have in this project privacy researchers also, but then we work together with the Ministry of Transport and Communications, and we give them input for renewing those regulations in Finland. So because we test in this real environment, so we might find something that would be really useful when creating the regulations. And then we have tested different kind of big data platforms, and we have selected the Lambda architecture to fit to most of our needs, but we have also tested distributed Flume ingestion for better ingestion rates and higher availability. But I was supposed to show you this Lambda architecture, nice picture, but now it's not available. So, but there's a user interface prototype. And Keijo Heljanko here is responsible of that. He's from Aalto University, so yes. And then connection to Tieto Analytics platform is under development. So we have Tieto representatives here as well, Matti Vakkuri and Olli, hopefully. Is he not here? He left already? Okay. That boring. Okay. So ongoing future, we want to extend to other cities in Finland, but of course now we are preparing Horizon 2020 efforts, so we could go to other Europe to test our systems. For example, this emergency vehicle system, and of course we want to do live pilots all over the world. We have a group of companies that can actually operate anywhere, so why not New York? And for the private sector, of course, we want to create new services. We want to exploit the data lake that we have collected at its full extent and demolish those silos I was talking about. But for the authorities, we want to give best practices for which equipment to choose, which kind of methods to use, for example, in taxation, in developing taxation. So this is also a new area that's going on in Finland. And of course, for research, we need more complex scenarios and more diverse data sets and novel algorithms for data fusion and machine learning. And so that's it. Thank you, because I cannot show the last slide of the collaborators, but we have 10 companies. Tieto is the leader company of this project. data to intelligent. And then as research institutes, there's University of Oulu, Centria, and Aalto University. And we work also with Helsinki University and Tampere University. Then the IMTech Peak and Traffic is responsible of providing the traffic signaling systems and data for that. Finnish Meteorological Institute, they provide services for weather. Noptel is the company that provides the laser range measurements. Mobisoft provides information about taxi cabs operating in Finland and also in other Europe. Then Triveco Easy Tools, they provide information about, or they provide services about personal driving behavior, and they have the device of OBD device. City of Oulu is collaborating with us, and Vidamin is responsible of the parking garage services, and InfoTripla is one of the integrators of the data. So during this 4-year project, we have already created new services for these different companies, and they are gaining profit on that. So if you want to operate in Finland, in Oulu, just contact us and we'll see what we can do. We have this mentality in Oulu that just do it. Okay, thanks.